To deal with interference efficiently and effectively in both lab and real-world environments, octoScope has developed iGen, a compact, powerful, and easy-to-use tool capable of generating many forms of RF interference. Chuck Ganamian, octoScope's Director of Sales, explains.
In real life, when you come to an apartment building or an office, you can see 30 or more networks in range. You'll also have other sources of interference in the unlicensed bands. But in addition to Wi-Fi, we now have the Internet of Things and LTE technologies crowding the unlicensed bands, and these technologies need to coexist.
Fanny Mlynarski is the president of octoScope.
Interference is a major problem today, and equipment that runs mission-critical applications, for example, set-top boxes which are enabled with Wi-Fi for video streaming, they are required to have complex technologies to adapt to interference. For example, automated channel selection. When a set-top box comes on the air, it needs to pick a channel with the least amount of load. Modulation adaptation and channel width adaptation to make to result in an optimum throughput for Wi-Fi. All of these technologies are complex and need to be optimized by engineers who develop them. And iGen helps you optimize these algorithms by creating controlled sources of interference inside the Octobox environment.
So what we have here today is the PAL-38 test bed. And inside what you can see is we've got the turntable, we've got the high gain Wi-Fi antennas, the LTE antennas in the back, dipoles on the side, and those are all on rails so they're movable and configurable for you. Underneath you'll see our multipath emulator. And on the sides, we have the instruments mounted. We have an octopal and an iGen on this side, and on the other side, we have two iGens. And they're on the side so that all the cabling is nice and neat and manageable. So on this side of the case, we have the octopal, which is the partner device talking to the AP inside the octobox. And behind it is the other iGen with a 3x3 connection going into the octobox for monitoring. This is the multipath emulator. It is powered and controlled via PoE or USB, and it is cabled from the octopal through the multipath emulator, out of the multipath emulator and into the octobox. There's also a quad attenuator in there, so if you need to program attenuation into your test, you can do that as well. All right, on the left side of the octobox, we have two iGens cabled into the two antennas that we showed you earlier in the video. So what we're showing here is some live data being transmitted from the octopal through to the access point in the octobox. And then what we're going to do is we're going to use the iGen to insert some noise, and you're going to see that throughput change. So as you're looking at this plot, you can see how the throughput dropped from 300 to 200 megabits per second when we turned on the iGen and added the interference.
iGen has two subsystems. The traffic is generated by this subsystem, which is based on the Qualcomm chipset. octoScope has access to the driver and firmware of the chipset to create special replay mode, whereby traffic can be generated by replaying capture files in a controlled manner we just discussed. Other common types of interference are generated by a built-in frequency synthesizer. The built-in RF switch and programmable attenuator control the power level of the interference. iGen is controllable via browser user interface, and every field you see here can be controlled by an automation script. It can generate Wi-Fi traffic or common interference such as Bluetooth, radar, and more. Just click Start to generate the selected interference. To generate traffic interference, iGen replays PCAP files. PCAP is a standard format used by common sniffers such as the Wireshark. A few captures are provided with the iGen, and you can add your own on the File Manager tab. Replay is fully controllable, with selections for 802.11 interface, channel width, modulation coding scheme, and other settings.
So what we're transmitting here is an 802.11 AC interference generated from the iGen, and you can see the signal here on the bottom part of the scope, and at the top you can actually see all the packets that we're transmitting as part of that 802.11 AC interference.
The wireless multimedia setting controls the priority of the interference. In other words, how aggressive the interference is. Why do we want to control this? For evaluating how co-channel interference impacts your service. Co-channel interference happens when two or more cells are on the same channel and within range of one another. All the APs and station in these cells have to use the 802.11 CSMA-CA contention mechanism to coexist in an orderly manner. CSMA-CA is also known as the Listen Before Talk protocol. Like a group of people conversing with one another, these stations transmit only when the air link is clear and back off in case of a collision. The wireless multimedia setting controls how quickly the iGen transmits after a back-off, and this sets how aggressive its traffic is. Let's take a look at a simple example. Here we see three iGens generating traffic on the same channel in the quiet, controlled air link inside the octoBox. Initially, we set the priority on all three iGens to be the same, best effort. Then we changed the priority on one of the iGens to video, and you can see how this iGen's traffic dominates and takes capacity away from the other two. Then we set the second iGen to the highest possible priority, voice priority. Voice is the most aggressive interferer, so the iGen lets you easily configure real-life co-channel interference of different types. The no back-off mode of replay is used to emulate adjacent channel interference. Wi-Fi spectrum spills into adjacent channels and causes interference. And if your link is operating at a low signal level, for example, it traverses a couple of walls, strong ACI can create challenging noise conditions. In this example, the noise from the adjacent channels is nearly as high as your signal. These are the pre-programmed types of common interference: Bluetooth, baby monitor, microwave oven, and radar. Radar interference is used for DFS testing. iGen comes pre-programmed with radar types 0 to 4. Each of these radar waveforms will cause channel switch announcement from the AP, and you can test the impact of the DFS channel switch. You can select the operating channel or enter radar frequency here. Click Update to have the new settings take effect. All the browser menu operations we reviewed in this video are available via API for automation of test sequences with varying traffic and waveform interference. Among the various provided sources of interference, you have the selection to play a custom interference profile. You can loop through the profile in two different ways. The interference profile is defined as a CSV file and can be loaded via the file manager. Traffic capture files for replay can also be loaded here. The format of the waveform CSV file is two columns: dwell in microseconds and frequency in hertz.
The iGen monitor mode provides powerful real-time monitoring of device under test adaptation behavior, including modulation coding scheme adaptation. octoBox is an automated wireless test workstation that makes engineers more productive, compressing test time from weeks to hours via sophisticated test automation and a stable, repeatable environment. octoBox supports the latest MIMO technologies and provides an ideal environment to evaluate even the highest levels of throughput available in contemporary implementations. It can emulate device motion and enable real-life impairments including path loss, multipath, and interference. iGen is a powerful building block of the octoBox wireless testbed, the most complete and productive wireless test solution available today.